Good morning, afternoon, evening, forever you're watching. You're welcome back once again to the Mickey Mouse Class, a channel so dedicated to demystifying mathematics, making complex problem look easy. Come along, there's a question on the probability that we have. It says a fair die is tossed to ones. What is the probability of scoring a 3 or a 6? This type of probability is what we call the mutually exclusive event. This is an example of a die. Now, a die has 6 sides: 1, the 2, 3, 4, 2, the 2, the second part of the die, the 3, third part, the fourth part, 4, 5, and 6. Now, if I throw this die up, it's not possible for me to obtain a 1 and a 3 at the same time. That is what we call a mutually exclusive event. The occurrence of one prevents the other from occurring. If 1 appears, the occurrence of 1 prevents 2, 3, 4, 5, and 6 from occurring. So that's an example of a mutually exclusive event, and we call it addition of probability. So with that idea, when we have something like this, solution, the probability, the first part of obtaining a 3 or a 6 will be the probability, addition of the probability of obtaining a 3. How many 3 do we have in this die here? Just 1, 3. Now, out of what possibility? What's the number of possibilities? There are 6 possibilities. When I toss the die, I can only have 6 outcomes. So the probability of obtaining a 3 is 1 over 3 plus, because the probability of obtaining a 6 also, how many 6 do I have here? 1 is also 1 over 3. So we add them together, 1 plus 1, that's 2. 1 over 6. 1 over 6, not 1 over 3. 1 over 6, because there are 6 possible outcomes, 6 sides of the die. So 1 plus 1, that's 2 over 6, which will give us 1 over 3. 2 here 1, 2 here 3. 1 over 3. The second one, probability of obtaining a 4 or 5, is the same thing as probability of obtaining a 4 plus the probability of obtaining a 5. Mutually exclusive event, I told you that's addition of probability. Now, it's different from independent events. So that's, let's look at this one. Probability of obtaining a 4 is 1 over 6 plus probability of obtaining a 5, because there's only one 5, is 1 over 6, which is equal to 2 over 6, which will give us 1 over 3. Now, a lot of students, where they make mistake is where you have 4 here now, you put the probability of obtaining a 4 to be 4 over 6. Don't make that mistake. There's only one 4 in the die, so the probability of obtaining a 4 is 1. Now, which is 1 over 3 here. When we do everything, the C part, it says probability of obtaining neither 6 nor 1. That means if I don't obtain a 6 or a 1, it means that I will obtain either a 2, or I will obtain a 3, or I will obtain a 4, or I will obtain a 5. Those are the number of possible outcomes. If I don't obtain neither 6 nor 1, that means I will either obtain 2, 3, 4, or 5. Now, let's look at the probability. So the probability of obtaining a 2 is 1 over 6, plus probability of obtaining a 3, 1 over 6, plus probability of obtaining a 4, 1 over 6, plus probability of obtaining a 5, 1 over 6. So 1 plus 2 plus 3 plus 4, 1 plus 1 plus 1 plus 1, that's 4 rather. That's 4 over 6, which is equals to 2 over 3. So the probability of obtaining neither 6 or nor 1 is 2 over 3. And the last one, it says probability of obtaining a 7. Probability of obtaining a 7. There is no 7 in this die. There's no part that is 7. They are labeled 1, 2, 3. There are 6 sides. So the probability of obtaining a 7 is 0. It's not possible for us to obtain a 7. I hope you have learned in today's class. If you learned in today's class, why not give us a like, give us a share, tell your friends about the Mickey Mouse Class, a channel solely dedicated to demystifying mathematics, making complex problems look easy. If there's any aspect of mathematics you are struggling, put in the comment section and I'll be there to attend to you. If you're here to subscribe, please kindly hit the subscribe button. Turn on the notification bell so you don't miss out on wonderful content on the channel. To meet again in the next class, keep practicing. Remember, mathematics is fun. See you at the top. Shalom.